Hello and welcome to this video, which is a walkthrough of the OCR GCSE Computer Science from 21st May 2024, and this is the paper 2, so the sort of the programming paper. It's the computational thinking, algorithms and programming paper. So just before we start, let's just have a quick look at the mark scheme, because it's always important. If anybody is my student, then you'll know that looking at the mark scheme when you're going through past papers is really important, because you learn what the exam board is looking for, but also you see how they mark it. So basically, we are looking for every mark is worth 1 point unless stated otherwise. Each mark point can only be awarded once. A word or phrase that is underlined needs to be the exact in the answer, and a bold is a concept in that answer. So this is really important, because some exam boards it's the opposite, where bold is the exact answer and underlined isn't. So just make sure that you are clear on that. And with the 3 dots at the end of a mark point, that means that you can only get to the next mark point if you've got that first one. But yeah, I'll go through that and I'll point that out. It's easier to understand what I mean by that when we see it in the mark scheme. Single / means it's an alternative word, and double is an alternative statement that's acceptable. All right, so let's start looking at this, and I'll point anything out on the mark scheme if anything interesting comes up. So no calculators on this one. And our first question, we advise you to spend 50 minutes on section A. So tick one box in each row to identify the programming concept where each keyword is used. And each time I'll give you a moment to pause, or a chance to pause the video before I give you the answer. Do try and do these questions yourself. Even if you do them in your head, it's always good to see sort of where you need to sort of revise. Okay, so the programming concept, if, is a selection. It's not an iteration. Selection means that you are deciding something in code. Iteration means it's a loop. So a for loop is a type of iteration, and a while is also iteration. And it's 1 mark for each of those. Okay, so our next question, we have got to draw flowchart statements. So the flowchart statements have been written in an algorithm, but the flowchart is incomplete, and the algorithm has is an odd number, is divided by 2, it will give a remainder of 1. So we're basically working out if it's an odd number, and we can see there that we've got our end. So this is just to get you to remember your flowchart symbols. Again, if you want to pause the video and try this, do give it a go. But I'm going to do the different things now. So an input or output is a parallelogram. And then we've got an if statement. So if it's an if, it's always the diamond decision box. And I'm drawing these absolutely atrociously. Hopefully yours. Yeah, no, that's really embarrassing. Let's just get rid of that and try again. I am not very good at drawing. And obviously I'm doing it on a graphics tablet, so I'm doing my best. All right, that's a slightly better one. So that's a selection, it's an if statement. We've got an output here, which is another parallelogram, and we've got an output here. But what we've got to do is we've got to add in the flow lines. So we've got start here, and then we're going down here, and then down, and then down, and then across here, and then down. Because we're getting the input, which is here, we're then checking to see, does it leave a 1 remainder? If it does, then it's odd, and if it doesn't, then it's even. There's no loop in this, so we're not doing anything, we're not going back up or anything like that. Now, one of the interesting things about the mark scheme with this is, if we look at that, if I can find the mark scheme, there it is, you will see that the mark scheme, the notes here on the right hand side, it says no need for arrows, lines are acceptable. So that's an interesting marking thing. And BOD, benefit of the doubt, for correct answers that include a loop back up to the start. So you know, there is no loop here, but they're not going to mark you down if you've done that. So, but try and stick to what there is. And also, interestingly, obviously, we've got true and false here for our if statement. And if you put yes or no, that's absolutely fine. So yes or no, or true or false is no problem. Let's look at the next question then. And the next question is state what is meant by the term syntax error. Give one example of a syntax error in a program. So we'll just do that part A first. And the answer to this is basically it breaks the grammar rules of a programming language. So that's the definition. And it will usually stop the program running because you have to make sure that you fix it. So if you want to also sort of give a real life example in Python, for example, then you should be able to get a mark for that. We'll look at the mark scheme actually and see how they're going to mark this. And it says, yeah, so it breaks the rules of the programming language. It stops the program running. So we could give an example like a keyword, print with a double T instead of print, a missing or extra symbol, anything that you can think of in whatever programming language you've done, a capital P for print instead of lowercase. So always kind of give the example, but also give the correction. Do not allow answers linked to data types. So that's an interesting mark scheme there. Incorrect grammar by itself is not enough. So you need to kind of pull it out and say it breaks the rules of incorrect, it's incorrect grammar. Do not allow it stops working or does not work. Do not accept missing quotation marks. For example, print hello could be a variable name. That seems a bit harsh, but there we go. And benefit of the doubt, given code that could cause a syntax error in a high level language. So again, it doesn't matter which language you've been doing. I think most people will probably do Python, but try and give one where, yeah, it's missing semicolon, etc. That's always a good one to stick to, or yeah, the incorrectly named function is a good one too. Move on to the next question, which is a student writes an algorithm to input two numbers and then add them together to create a total. If the total is between 10 and 20, success is output. If the total is not between 10 and 20, a warning is output. So this does not work correctly. Identify the line number of two logic errors in the algorithm. So not syntax, so we haven't misspelled anything or anything like that. We're just looking for logic errors. Again, pause the video if you need to. Okay, so I like to do these questions by looking at every line one by one. So we've got the first line, we've got num1 equals input, enter a number. So this is basically semi-Python. It's not 100% Python, but it's very similar. Anyway, num1 equals input, enter a number. That looks okay. Num2 equals input, enter a number. That looks okay too. Total equals num1 plus num1. Okay, so that's our first error because it should be num2, not num1. So that's our first one. So line number 3, and the correction would be total equals num1 plus num2. And then line number 4, if total is greater than 10, then, right, so that's wrong because it's got to be between 10 and 20. So that's our second error. It's line number 4. So we found this quite quickly. If total is greater than 10 and total is less than or equal to 20, then. So we do that as well. Right, so the correction is if total is greater than or equal to 10 and total less than or equal to 20, then. And that's our 4 marks. I'm just going to check the other lines. Yeah, print success, else, end if, print. Yeah, that's all fine as well. So let's just have a quick look at the mark scheme. I just want to have a look at the mark scheme because just want to check the notes here. So it says allow other logical corrections that will fix the problem identified and does not produce further errors. So I'm not quite sure. Oh yeah, so they've got actually they've got it here. So if we've got int num1, so we're casting our inputs to a integer. And also this here, this is a good way, the second one, if 10 less than equal to total, less than equal to 20, that's just a shorthand way of using and. So it's just a different way of doing it. Allow descriptions of changes as long as clear exactly what will change. Do not allow ambiguous descriptions of changes to code. Ignore the missing then. So if you forget to put that then, don't worry about that, and ignore capitalization. So quite a few different sort of things to note for interest in that mark scheme. Let's move on to the next one. So our next question, show how a binary search will be used to find the number 10 in the following data set. And we've got 3 marks for that. So for this question, we're just writing a very brief overview of how a binary search works. And binary search must have an ordered list, so you can see they're in the right order. And what it does is it finds the middle. So we've got 1, 2, 3, 4, 5, 6, 7 items in this. And the middle one, therefore, is the number 6. So we've got this side and then this side. The first thing it does is it checks to see, is the number in the middle the number that we're looking for? Is 6 what we're looking for? Is 10? It's not. So it will then say, is 10 greater than 6 or is it less than 6? Well, it's greater than 6. So it will discard all the ones that are less or on that left side, and it will then use that other list here, and it will discard the central one there because we checked already it's not that number. It will then look on this side and search for the central one, which is 10. It will say, is that what we're looking for, the central one? It is, so it's then found it. So that's the way that the binary search works. And actually, I've just answered part II here. It says state one prerequisite for a primary search, that it has to be an ordered list. Okay, so to write this in 3 things, let's just see how we can write that in 3 sort of short bullet points. If we look at the mark scheme, they've got here, we compare and pick out the middle value, which is 6. We discard only the left side, retain only the right side because 6 is less than 10. And then we compare, pick out the middle value, which is 10, and therefore we found it. In the mark scheme, it says here, mark point 1 can be given for generic answer. Points 2 and 3 must be linked to the data set given. So you must not sort of use different numbers that are in the data set. Just make sure you stick to the example they've given. And then for mark point 2, where we're discarding only the left side, etc., you must remove 1, 2, 5 and 6 from the list if discussing individual members, and allow for bullet point 2 if this is done, so follow through, FD's follow through, if this is done correctly. So I mentioned earlier about the ... dots. This is a good example. So this second point here, where we discard only the left side, retain only the right side, we've got a ... So that means that you can only get the third point here if you've got this second point awarded in the middle. So that's what the ... means, and then a ... at the bottom. If that bottom point didn't have a ... then you could get the third point without getting the second point. I hope that's clear. Okay, I'll point out any others that come into the questions. Okay, so we've done that second one. Tick one box to identify the name of the sorting algorithm that splits the data into individual items before recombining in order. Is it bubble, insertion, or merge sort? And the answer to that one is it's merge sort. It's the third one. Merge sort basically splits everything out and then adds it back together, funny enough, is what they're saying in the question. Okay, next question. A programmer allows users to search for and watch videos. Users give a rating to the videos they watch. Identify one input and one output for the program. Okay, so for this one, there's actually lots of different things. If you're searching and watching videos, then we're just kind of thinking about, you know, what does the user input? Well, it could be the name of the video, could be play or pause, could be the rating of the video. And then for output, things like the results of the search, the number of views of the video. So there's lots of things here. Let's just have a look at the mark scheme actually. And we've got, so yeah, the name of the video, controls for watching it, rating of the video, and then output could be video to be watched, results of the search, overall average rating, the number of views of the video, confirmation of data entry, messages to the user, and quotation marks. So it says there on the notes, allow input print pseudocode statements if it meets the mark points, does not have to be valid pseudocode. Do not allow examples of inputs, e.g. music videos. On to the next question, part B of this one. Describe one method of defensive design that can be used when creating a program. So defensive design is all about making sure that the user can't do stupid things, basically. And there's lots of things that we could put here. Actually, what I'll do is I'll show you in the mark scheme because there's so many different things you could put here. We've got authentication. So checking that the user is allowed to access that website, username, password. Anticipating, so actually, by the way, you've got the ... It means that you don't have to get the previous point. So authentication, you don't have to put that to get the second or third bullet points there. So because there's no ... after authentication, so that's fine. Anticipating misuse, preventing misuse, so making sure they can't hack the system. Validation, making sure that the data is sensible that we're putting in. Individual sanitization, so removing invalid special characters. You can give an example of that. And then maintainability, ensuring the program is able to be understood by others, for example, modularization and comments. And then just our different notes here. Allow validation, input sanitation, passwords as expansion of anticipating misuse. So username, password for making sure they don't try and hack or something. Allow a mark for description with no incorrect name. So that's what I mean by there's no ... after each name. And then allow any 2 points from the mark scheme as long as it's clearly linked to a single defensive design method. So you've got to kind of stick to one and not go into two different ones. So you can see it is really important to look at the answers because by doing that, you can see how they expect you to answer it. Because if you sort of pick two different things and thought, oh, I can think of something else, I'll put that as well, to try and get your second mark, you wouldn't have got a mark. You only get one for each type. Okay, on to the next question, which is a truth table. So for this question, we have got to do the truth table for this. We've got P equals A and B or C. So if you can try and do this, pause the video. So for this question, they haven't actually given you any space to put the intermediate values, but let's just look at our truth tables for our logic gates for this. We've got and we've got or. So actually, I'll do it on the same line. That might be slightly easier. So we've got A, we've got B, we've got and we've got or. So 0, 0, 0, 1, 1, 0, and then 1, 1. And for an and, if we've got a 0 and a 0, that will be a 0. 0 and a 1 is a 0. 1 and a 0 is a 0. And then 1 and 1 is a 1. So with an AND gate, we only get a 1 output where both inputs, A and B, that's the whole point of it being an AND, is 1. Now with an OR gate, if we've got 0 and a 0, then we get a 0. 0 and a 1, it's a 1. 1 and a 0, it's a 1. And then 1 and a 1, it's a 1. So basically, if any of the inputs are 1 with an OR, then we have a 1 as an output. So I'm going to do an intermediate value here because we've got to find this. We've got A and B. So I'm going to call that output D. And I'm just going to sort of put it here. And then I'm going to take A and I'm going to AND it with B, each row, and then write the answer in D. So we've got 0 and 0 is a 0. 0 and 0 is a 0. By the way, we're just ignoring C for the moment. Okay, so just ignore C. 0 and a 1 is a 0. 0 and a 1 is a 0. 1 and a 0 is a 0. 1 and a 0 is a 0. But we've got 1 and a 1 is a 1. And then 1 and a 1 is a 1. Okay, so that's the D part, or the A and B in the brackets in that expression. And then we're basically taking that, what is D, and then we're going to OR that with C. So we're going to take C and then D, and we're going to OR it for each row. So the answer is a 0, but we've got a 1 and a 0, so that's a 1. 0 and a 0 is a 0. 1 and a 0 is a 1. 0 and a 0 is a 0. And then we've got a 1 there, we've got a 1 here, and then we've got 2 1s, and that is our truth table. Okay, let's have a look at the next question, another question on logic gates. Okay, so for this one, we've got not A and B or C. Okay, so with this question, all we do is we look for the central gate. And the central gate is anything that's not, any gate that's not in brackets. It's not usually a not, by the way, because that not there is associated with A. So our AND here isn't in any brackets, so that's our central gate. And our central gate always goes here, which goes to our output. And it's really important to remember that there's only ever one gate that goes to that output, because you can only ever have one line going to it. So I'm going to draw my AND gate here. And I always prefer to write on it what it is. You don't have to do that, but I kind of recommend you do. All the AND gates have 2 inputs, as well as the OR gates. So on one side, we've got not A. So on one side of the AND gate, which is side 1, this is side 1, we've got not A. So I'm going to come here, and as long as I draw a not gate anywhere before it goes into this, then that is our not A. Not A. I'm just going to draw my circle there. And then on the other side here, in the brackets, we've got B or C. So it's an OR gate. So I'm going to draw an OR gate, probably very badly because I'm not very good at drawing these. Oh, actually, that's not too bad. There's my OR gate. And coming into that is B and C. And there is my circuit. Now, it's important to know on the mark scheme that you must get the shapes correct. So but the only reason I say write on it is because it can be a little bit ambiguous sometimes. So if we just have a quick look at the mark scheme here, it says if it's not logically correct, so maximum 2 marks if it's not logically correct or any additional missing gates. Shapes of gates must be correct with the correct number of inputs. Ignore annotation of gate names. Well, I've put it on, but yeah, other exam boards do actually allow you, if it's clear. So try and do your best. The NOT gate must include a circle. Other gates must not include a circle. So that's important, because actually if you have a NOT gate, quick little tip here, a NOT gate like this without the circle is just what we call a buffer, and it's just passing a signal on as it is. So that's why you must get that shape right with the circle on the front. Okay, on to the next question then. And this question is a variable message is assigned a value. Message equals ABCD1234. Complete the table to show the output when each statement executes. So they've given an example, print message.length is 8. So what would message.upper be? Message.left 4. So this is substring for those of you who have not done that. And then we've got int message right 4 times 2. Remember your bid mass in that one, do the brackets first. So let's have a go at these. So we're just putting it to upper. So all we do is we put the A, B, C, D in uppercase. So A, B, C, D in uppercase. And then 1, 2, 3, 4 can't be upper or lower. It's just the same. And then message.left, we're basically taking the first 4, because it's 4 digits from the left. So if we take that, we've got A, B, C, D. That's the first 4 letters to the left, A, B, C, D. And then we've got right 4 and then times 2. So we're going to take the number from the right 4. So that's 1, 2, 3, 4. And then we're going to times that by 2. So 1, 2, 3, 4. Add another 1, 2, 3, 4. If we're timesing it by 2, I just add 2 together. So that gives us 4 plus 4 is 8, 3 plus 3 is 6, 2 plus 2 is 4, 1 plus 1 is 2. So it's 2, 4, 6, 8. Okay, so just a quick note in the mark scheme, it says that you can, let's just have a look at the mark scheme. In that question, you can allow quotation marks in the answer, so that's absolutely fine. Okay, let's look at the next question. Next question. Write an algorithm in pseudocode to store hello in the variable word1, store everyone in the variable word2, and then concatenate word1 and word2 to store hello everyone in the variable message. So for this, just remember that concatenation is adding two strings together. So we're going to do this in OCR pseudocode effectively. Yeah, in OCR pseudocode. So it's basically word1 equals hello. I'm sorry, my graphics tablet is a little bit slow. If I don't do joined up, it's very, very slow. There's a slight delay. I don't know why it's got that. And then we've got word2 equals everyone. I'll do it as joined up. You'll do it really neatly though, unlike me, and quotation marks. And then we're going to concatenate them for the variable message. So that is message equals word1 plus word2. So it's just literally the plus sign, and programs know that if it's two strings, then it just concatenates them. Obviously, you can't add together numerically two strings, so it will always concatenate them. Okay, let's look at the mark scheme for that. And the mark scheme says, a few notes there, except the ampersand or plus or dot for concatenation, allow use of sensible concatenation functions like concat. Do not allow commas. Do not allow double equals for assigning values to a string. Do not allow spaces in variable names. So that's really important. So just general programming rules. Ignore additional code given, ignore case. Reasonable attempt at bullet point 2. So the first one in order to get the third one. So you've got to make sure that you do word1 equals hello, word1 2 equals everyone before you can get the final one, the final mark, which is fair enough. Next question, programs can be written in high-level languages or low-level languages. Give 2 reasons why some programs are written in a low-level language. And then for 3 marks, describe the benefits of using a compiler instead of an interpreter when writing a program. Okay, so there is a number of reasons why we would use low-level languages, and the main one is kind of if you want direct control of hardware. So we will use it for controlling components inside a computer. So that's really why we would use them, and it is usually faster as well. Although it can take a lot longer to code in low-level languages, execution time is usually much faster. And you usually get quite a lot of really good control of the memory with low-level languages. So that's another thing that you could put. Let's have a look at the mark scheme though. I think I might have left a couple of things off. So yeah, so machine code or low-level does not need to be translated, compiled or interpreted. Direct control of hardware or memory, faster execution time, code can be optimized or use less memory, can program for specific hardware, and assembly language is fast to translate. So yeah, so assembly language is a type of low level and you still need to translate it because it's not quite machine code. So the difference between machine code and assembly, machine code is literally the sort of the binary that's been used to control the components. Assembly language is a type of low level language that's very close to machine code, but it still does need a little bit of translation. Not much, but it still needs doing. So it says more efficient by itself is TV, and TV means too vague. So just be careful of that you're not vague. Mark first answer on each line, and then bullet point 6. So it's 1, 2, 3, 4. So the last one, assembly language is fast, relates to assembly language being a one-to-one direct mapping to machine code. So yeah. Next question of that one was that we're describing the benefits of using a compiler instead of an interpreter. So we're now moving on to high level languages. So compilers and interpreters are only used for high level. And yeah, there's lots of things you can say about this. Let's just have a look at the answer. Can produce an executable file. So with that, it gives you everything that you need. So when you're writing code and you're releasing it, you need to, just releasing an executable file is all you need to give the person who wants to run the program. Whereas if you have something like Python, which is interpreted, you need to make sure that the person has Python installed on the machine. So that's a little thing that extra you need. And it's the same with languages like Java that are translated via an interpreter. So yeah, so program code runs faster with an executable or a compiler. The end users, like I said, do not need that translator, can be run again multiple times and only needs to be translated once. So we translate it, but the developer translates it. Whereas with the translator that is the interpreter, it's interpreted and translated as the user runs the code. So they could potentially steal the code if you don't obfuscate it. So yeah, potentially there's some issues there. Allows all or multiple errors to be shown, and the compiler can optimize the code as well. So it says allow in reverse, e.g. interpreter translates every time. So you could just sort of say why interpreters aren't good, and you can do that usually with any question, do the opposite. Do not allow no access to source code unless clearly talking about the end user. Do not allow descriptions of how a compiler translates. So yeah, make sure that you're always looking at why you would use it, not how. Okay, and yeah, faster, quicker by itself is too vague. Okay, next question. An algorithm stores the position of a character on a straight line as an integer. A user can move the character left or right. So basically you've got a little character. If I can get it to draw, there you go. So I've got a little character and our character is on a straight line and you can get them to move left or right, but they can't go up or down. Okay, so a user can move the character left or right. The following algorithm generates one random number between 1 and 512, inclusive, to store as the position. It prompts the user to input a direction to move left or right. So it's a bit like controlling a turtle. Takes a direction as input until a valid direction is input. Describe 2 ways to improve the maintainability of this program. So there's nothing wrong with this code. So it generates, so it works, it generates a random number, it prints that position, we set a variable called a to blank, but then while a is not equal to left or right, then we ask the user to input left or right, and then we end while. So how would we make this more maintainable? So what I would suggest is, first of all, I hate variables where we just use, apart from a for loop where we're doing for I, having variables just of a letter is not a good way. So make sure you have meaningful identifiers. So we would say in there, meaningful identifiers, because otherwise we don't know what the purpose is of those variables. So P could be anything, but P should be something like position. So meaningful variable names, and sorry about my handwriting, i.e. P should be position. And A could be, instead of A, I would have direction instead of A. And then another thing that we could do, there's no comments on here. So I would add comments to make it clear what each piece of code is doing. Because otherwise it's going to be quite tricky to know, if you've done, comments are really important. And the reason being is quite often you'll be writing lots of code, you've done something, and then you come back to it and you think, what on earth is this? Especially if you've done something a bit weird to get around a problem in your code, then having a few comments in there to say, I had to do this because of whatever reason. So that's another one. Now, other things as well, Actually, let's look at the mark scheme. So those are always two that, to make code better, meaningful names, comments, but there is a couple of other things. And we could put use of subroutines. So reuse blocks of code. So put a function or a procedure, and you can give an example of that if you want to, which would basically be getting the user input. Use of constants. So constants are just like a variable, but once the program runs, they don't change. So the only way you can change a constant is by changing the source code, your code, and then stopping and starting the program. And they're very helpful for all sorts of things. But in this case, we've got, 512 could be a constant because that's not going to change, or it shouldn't change for the side of the screen effectively. Notes on this: do not accept what variables do, incorrect verb, variables store hold data. Benefit of the doubt for comments: do not allow instructions, do not allow indentation because that's already done, and obviously it's very important for some programming languages. Allow white space, blank lines as well could help you read the code more, but it says do not award expansion without being clear which method it is being discussed. So make sure you're clear on that. You've got two things, put for each question, make it clear, and don't mix them up. So don't mix up answer 1 with answer 2. Makes it easy to understand by itself is too vague. So we're always trying to be as clear as possible. Okay, on to our next question where we're going to have to write some pseudocode. So it says if the character moves left, 5 is subtracted from the position. If the character moves right, 5 is added to the position. The position of the character can only be between 1 and 512 inclusive. The function move character takes the direction left or right and the current position as parameters. It changes the position based on the direction. It sets the position to 1 if the position is less than 1, and sets the position to 512 if the position is greater than 512, returns a new position. Complete the function move character. So let's just remind ourselves though what we've got. We've got from that previous code, we've got our little character and we're moving it left or right, and it's on a straight line, and the maximum on this side is 512, and then the maximum on the other side is 1. So that's the side of the screen basically. So we're going to move the character 5 places that way, or 5 places if it's right, less that way basically. If it's left, -5 if it's left, +5 if it's right. So that's left, that's right. So basically what we need to do for this is look and say if the direction is left, then -5 on the position, and then you return that position. So we're getting that in. And else, if the position, or we're going right, if the direction is right, then we +5. But once we've done that, we need to check. So we say if the position is greater than 512, then it equals to 512. And then if the position is less than 1, then it equals 1. So let's have a look at that. So try and write that though. So obviously I'm going to show you the answer in a moment, but try and write that logically. It's just 2 if statements. One to check the direction, is it left or right? Reset the position, -5 if it's left, +5 if it's right. And then another if statement where we check, is the position greater than 512, then it equals 512. And if it's not, if it's less than -1, then it is, if it's less than 1, then it's 1. And we must return the position as well. So we're looking at the answer now for that, and basically here's the code. So we've got 2 if statements. If the direction is left, then the position is position -5. Else if, so they've got else if, you could put if, that's absolutely fine. If that is equal to right, then the position is position +5, and don't forget the end if. But then we need to check, is the position less than 1? Then we set it to 1, and if it's if it's greater than 512, then we set it to 512. And again, don't forget the end if. You could put those in the opposite way. Obviously, you could check for right first and then left. It doesn't matter. And we must return the position. So we're marking it basically appropriate use of both parameters coming into the function, an attempt at selection, correctly checking if direction is left and subtracting 5, correctly checking if direction is right and adding 5, ensuring that the position is between 1 and 512 and returning the updated position. So that's really important to return that. So just says, yeah, you can use less than, equal to, and equivalence. You can't get bullet point 5. So 1, 2, 3, 4. So 1, 2, 3, 4, 5. So you can't get this one here unless you've done the previous 2. Bullet point 6. So returning the updated position will only be given if you've attempted the calculation. Ignore repeat of the function header. Accept a flowchart or structured English. If response uses a loop to incorrectly change the position multiple times, do not award bullet point 1. For minor syntax errors, penalise once, then follow on through. So you can lose a mark for incorrect syntax, but only once. So that was section A, and then it says we advise you to spend approximately 40 minutes on section B. And it says there some questions require you to respond using either OCR exam reference language or a high-level programming language that you have studied. These are clearly shown. Students take part in a sports day. The students are put into teams. Students gain points depending on their result and the year group they are in. The points are added to the team score. The team with the most points at the end of the sports day wins. Data about the teams and students is stored in a sports day program. Identify the most appropriate data type for each variable used by the program. Each data type must be different. So we've got team name, in quotes, super team, student year group, 11, javelin throw, 18.2. So the first one, because it's in quotes, it can only be a string. So the first one is a string. If my graphics tablet will work, there we go. First one is a string. Second one is a whole number, so that's going to be an integer. I think you can put int. I would just put the whole thing, put integer, obviously more legibly than me. And then javelin throw 18.2, because that is a floating point number, we can either say a real or you could say a float. Either of those is okay. Okay, next question, or actually before we do that, let's have a quick look at the mark scheme in case there's any notes. And it does say, yeah, accept alternative equivalent to the correct data type. So single, double, decimal for bullet point 3. Do not accept char for bullet point 1. So char is different to a string because char is 1 character. And obviously that string had more than 1 character. Okay, next question. The student names for a team are stored in an array with the identifier the team. An example of the data in this array is shown. A linear search function is used to find whether a student is in the team. The function takes a student name as a parameter, returns true if the student name is in the array, returns false if the student name is not in the array. Complete the design of the algorithm for the linear search. Remember, linear search, we're just checking each item one by one to see if the item is in the array. So is that what we're looking for here? No, then it moves on to the next one. Is that what we're looking for? No. Or yes, depending on what it is supposed to do. So again, try this yourself. Pause the video and see if you can work out what the missing statements are. Okay, so we've got our function, linear search, student name. So that's what we're looking for. And we've got for count equals 0, 2. So how are we going to do that? Well, there's a number of different ways you could do this. We could do the team.length. That would be okay. So we could say the team.length. That's my preferred way, because that means you can change if the size of the array changes, then you don't have to rewrite your code. But in this exam, you could put, instead of that, you could put 5 because there's 5 in there. You want to do one less. Or you could do, oh, sorry, and it's the team length -1 because it is a 0 indexed array. And then we've got if the team, and then this will be count. So wherever we are looking at in the array, 0 to start with, is the same as the student name, so what we're searching for. Then return that we found what we want, so we return true. And you can see there, we return false if not. So it's always important to learn linear search as an algorithm. It's important anyway to sort of search for it. If we look at the mark scheme, we have got a few notes. You can accept the team length as well, if that was because that would be Python. We could accept alternative length functions like len instead of length. Accept count equals 5. Accept true for bullet point 4. And yeah. Do not allow obvious spaces in variable names. Ignore capitalization. So that's fine. Okay, next question. This algorithm calculates the number of points a student gets for the distance they throw in javelin. Now we're going to do a trace table for this. It says complete the trace table for the algorithm when a student in year 10 throws a distance of 14.3. You may not need to use all the rows in the table. So it's really important when you're doing trace tables to remember that they're here to track variables and what's going on with variables. So unless you've got something that's setting a variable or is outputting as well, so ignore the output for now, but we've got 3 variables: javelin throw, year group and score, and all we're going to do is we're going to check to see where are the variables changing. So follow through line by line, and it's just literally there's no loop in this, so we're only going to do it once. So javelin throw input enter distance, and it says here year group 10 we've got 14.3. So on line number 1 we're changing it, and javelin throw is 14.3. We're going to go to the next line, line number 2, year group equals input enter the year group, which is year 10. So that's line number 2 and year group 10. So that's that line. Line number 3, if javelin throw is greater than equal to 20. Well, it's not, it's 14.3. So we're not going to run line number 4. We're going to jump to line number 5, which is elif. The javelin throw is greater than equal to 10. It is. So line number 6, we have a score of 2. So we change the score to 2. Okay, and then we can go to the else. So we don't need the else because we've done the if. So you never do the if, it's one or the other. We then go to line number 10. Line number 10 says, if the year group is not equal to 11, so that's right, it's 10, the score is the score times 2. So 2 times 2 is 4. So that's line number, is that line number 11? Yeah, line number 11 is, our score is 4. End if, and then we print the score is score. So we put line number 13. The score is 4. And there's our trace table done. So again, always just looking for where we're setting a variable, how are those variables changing? Let's look at the mark scheme for that, because there is a couple of points to look at on this. And really we're looking at, yeah, so maximum 3 marks. So you're getting 1 mark for the javelin throw is set to 14.3 in line 1 and year group set to 10. Score set to 2 on line 6, on 4 on line 11, and then the final mark for line 13. So it does say that if the wrong order or additional incorrect changes penalise line numbers once, then follow through. So if you do it in the wrong order, you will get the marks, but well, you'll lose 1 mark basically if everything else is correct. Allow follow through for bullet point 4, so the last one, if the current value is correct. And bullet point 4, so the output must not include a comma. Ignore superfluous spaces, ignore quotation marks. Treat any entry in output column as an output, even if x minus or 0. Okay, so the next question is the height a student jumps in the high jump needs to be input and validated. The height is entered in centimetres and must be between 40 and 180 inclusive. Write an algorithm to take the height jumped as input, output valid or not valid depending on the height input. And you can use either the OCR exam reference language or pseudocode, or a high-level programming language that you've studied. So the mark schemes always have the OCR exam reference, and that's what we'll look at. But the key thing for this is just a range check. So it's literally just a range check. We use an if statement, and you can either check to see is the value input between 40 and 180, or you can check is it outside of that range. It's totally up to you which way you do it. So if we have a look at the mark scheme actually for this, then we've got the marking points are that you input the value and store it. So we've got that here. We're checking for valid input for this one. We have a variable, we input it, and then we check to see is that between 40 and 180 inclusive. So we need the equals there because it's inclusive. And if it is, then we print valid. Else, we print it's not valid, and then we end the if. There's no loop here, we're just entering it once. And I said you can check to see if it's invalid input. So in this case, we're inputting it again with h equals input. And then we have if h is less than 40 or it's greater than 180, then it's not valid. Otherwise, it's valid. So it's up to you which way you do it. Guidance here for the marking. So basically to get, so answers using and or for bullet point 2, so for the min and the max values, must be logically correct. Answers using or will reverse output for bullet point 4, so you're checking whether it's valid or invalid. So just logically correct basically for the if statement. You can make a reasonable attempt to get a mark for bullet point 4. Allow follow through if a reasonable attempt at validating is there. Ignore conversion to int, so you don't have to worry about the int input. You're not going to get a mark for that or you won't lose a mark if you leave that off. And greater than less than symbols must be appropriate. So yeah. Okay, the next question then is the algorithm is tested using a range of tests. Complete the table to identify an example of test data for each type of test. So we've got normal, boundary and erroneous. So valid, valid, not valid. What would we put in here? Now there's lots of different examples. What would you put? So for normal data, if we're testing between 40 and 180, then what is normal data? It's going to be somewhere in that range. So any number between that, maybe 100, we could say. It's 100 centimetres. Anything in that is fine. You don't need to put decimals, by the way. Boundary, then that's going to be right on the edge. So it's either 40 or it's going to be 180. Either of those is going to give you a mark. You don't have to put both, you just have to put one. And then erroneous is anything that's outside the boundary. So, -5, anything like that. Or you could put something above 180, so 182, for example. So now we're on to the database question. It says an individual results for each student in each event are stored in a database. The database table TBL results stores the times of the students in the 100-metre race. Some of the data is shown, and we've got a column for student ID, year group, team name and time, so that's our fields, and then we've got some rows as well. Complete the SQL statement to show the student ID and team name of all students who are in group 11. So yeah, so select student ID. So we're selecting the team name. So we've got student ID. we need team name. Of all students who are in group 11, but we need to put from TBL result. And one of the reasons why you have to put that from is many databases have multiple tables, so you need to be specific as to which table you're using. And it is required anyway, but for SQL, but that's fine. And then it says any students who are in year group 11. So we would say where year group, so it's the year group column, equals 11. So that's the SQL for that. Just a quick thing about the mark scheme then, answering this question. There's no need, oh, that's the other ones, the other question that we just looked at. So ignore capitals, do not accept asterisks for additional fields. So you can put select star instead of select the actual column names. So make sure you don't use that. Spelling must be accurate. Yeah, always be careful of that actually. So it's TBL result, not results. No spaces in the field names. Penalise obvious spaces and then follow through. Except for bullet point 4, double equals, that's absolutely fine. Okay, so yeah, you can see, looking at the mark scheme, I know I said it before, I keep saying it, looking at the mark scheme is really important, and it can really elevate your grades if you know exactly what to look for and make sure you don't make those mistakes. Okay, on to the next question. Abstraction and decomposition have been used in the design of the Sports Day programme. Identify one way that abstraction can be used in the design of a programme, and identify one way that decomposition has been used in the design of this programme. So really what they're getting at for this question, you want to pause the video before I tell you the answer. But what they're really getting at for abstraction is, with abstraction, all you're doing is you're removing anything that's not relevant to it. So you can see previously when we looked at the question, it's all to do with sports day, nothing to do with the school play that they're doing or the computer club that they're at. So we could just give some example of that. So it's just to do with the students' sports day and events that they've done and the schools that they've got and nothing else. And that's what abstraction is. And then identify one way that decomposition has been used in the design. Well, we've used, ultimately, decomposition is breaking problems down into smaller chunks. And we saw actually that, you could talk about breaking things down into smaller groups. So, I'm just looking at the examples that they've got on the mark scheme. They've got split the program into different events, separate the validation routines into subroutines, breaks the database down into a per table event. So that type of thing. So try and give a real life example where it does say give an example. Make sure you do that. So it says in the notes, it must be applicable to this program, not a generic description, but give the benefit of the doubt when it's unclear. Do not give answers discussing splitting into fields, so split into student ID year group. The benefit of the doubt of the answer discusses one table but suggests other tables could be used. Do not give answers relating simply to the data being split into smaller groups. Allow references to sports day to mean the sports day programme. Okay, so yeah. Let's look at the next question. So this next question is the final question of the exam paper. Well done for getting this far, if you've got this far. Not many people have. An algorithm works out which team has won or who has the highest score. Write an algorithm to prompt the user to enter a team name and score, or to enter stop to stop entering. Repeatedly take team names and scores as input until the user enters stop. Calculate which team has the highest score. Output the team name and score of the winning team with an appropriate message, and you can either use OCR, reference language, or a high-level programming language that you have studied. So you are writing the code for this, and there's 6 marks. They haven't given you much space, so that should indicate to you that actually there's not many lines of code for this. So pause the video and see if you can attempt this. And kind of remember the heart of this is we're finding the highest score. So we need to have a variable to keep that highest score. It's just finding the maximum and it's a standard algorithm for that. So I'm actually going to program this in Python. I've decided I'm not going to just look at the mark scheme. There's the mark scheme, but we're going to look at programming this. Obviously you're not going to have a computer to do this in the exam, but I'm going to take it step by step to show you how I would do it. So we prompt the user to enter a team name and a score, or enter stop to stop entering now. And it repeatedly takes the team names and scores as input until the user stops. So actually I'm going to do bullet point 2 first. Repeatedly take team names and scores as input until the user enters stop. So first thing I'm going to do is I'm going to create a variable and I'm going to call it team name, and I'm going to set it to be blank, and then I'm going to say while team name is not equal to stop, then we're going to prompt for the team name, and that's going to be an input. Enter the team name, and then we're also going to get them to enter the team score. So that's getting the team name and the score. Enter team score. Okay, so that's our first bullet point. It says, so we're repeatedly taking the scores until they enter stop. Actually, it's lowercase. I've put it uppercase. So let's just put that lowercase just in case. Prompt the user to enter the team name until they enter stop. Calculate which team has the highest score. So our standard, what is the highest score? So I'm going to create highest, and that's going to be a low number. So if we're finding the highest, you always need to set it to be a low number. And we're going to say, if team score is greater than highest, then highest equals team score. And press enter. And that's it. I think that's all we need to do. Calculate which team has the highest score, output the team name and the score of the winning team in an appropriate message. Oh, actually, so we need to store two things, actually. So not only do we need to store the highest, but we need to store the highest team. So highest team equals blank. Okay, so here we need to set highest team equal to the team name. And that should it. We just need to output that. So I'll just put print high score, or highest team name. Highest team. There we go. I can't spell can't spell today. Highest team. There we go. It's done it for me. No, it hasn't. Is that correct? Highest team. There we go. Thank you. It's corrected it for me. All right, so I'm going to run that and I'll just add in some data. So it said enter the team name. I'll just put some made up data. X, highest score 78. Oh, and we've got and I've forgotten big hello. What have I done here? I need an int input instead of a string. If you were doing this in the pseudocode, you wouldn't need to do that. Not necessarily. So I'm just going to make it up. Okay, team A. And I've done it on both names. I don't need to do it on both. You're watching this in real time. Let's try again. And we get rid of one of those as well. There we go. Run it. Enter the team name. Team A. Let's try. Finally, hopefully we'll get there. Team A. Enter team score. Team B. 45, team C 90, and then I'm going to put in stop. And you can just see at the end here, it was team C with 90 that was the highest score. Okay, so that is that code. Let's look at the mark scheme though, because there is lots of variations with this. Like, you know, there's lots of different ways to do a similar thing. And what have they got in their mark scheme? They have got example 1. So basically the marks are, we input the team name and the score separately. We attempt using iteration, which I had a while loop, to enter the team score until stop is entered, which was correct. It calculates the highest score on the winning team name, outputs the highest score and the team name. So that's fine. But you won't get any marks for outputting unless you do the previous points. So their first example, it's in their pseudocode or program code. So that's almost identical to what I did. And then in this one, they've got an array. So you could use an array for each one. And you're appending to the array. That's absolutely fine. And just storing the index of that team. What have they got in here? And these are just examples. So if yours was different, that's absolutely fine. It's if it matches what it does, then you still get marks. So you can use break in your example, and you can use recursion if you want to. Initialization of variables is not needed. Ignore multiple teams could get the same high score. So that's a good point. You could have the same, you know, but in my example, 2 teams with the score 90, just ignore that. Yeah, could be done in many ways. So as long as you're doing it correctly, that's the main thing. And for minor syntax errors, you can penalize once, but follow through. So that's fine. Yeah, input cannot be used as a variable name. And that's always goes without saying anyway. Okay, so that is the final part of this paper. I hope that's helped. Don't forget to like and subscribe.